Welcome once again. This is the continuing saga of my Fiarduino project. If you saw the first video, the whole project was to bring fuel injection to originally carbureted 1.8 liter bone stock cam, stock pistons, stock everything. It was a fresh rebuild, but that was it. I acquired a stock fuel injection intake manifold, paired it with the Arduino board, did a bunch of tuning through Studio, and was able to get a pretty significant power increase just by getting more fuel, more air into a stock 1.8. In some respects, it was a little disappointing. I realized it's a stock 1.8 with stock US compression, which isn't much. But I thought there was so much more that this engine could do, or its bigger brother. When I originally purchased this intake manifold, it came with a good core motor, and it was actually a 2 liter, not a 1.8. So it just kind of sat there on the stand while I was doing all this other work, and I started to wonder, could we do better? So I decided to tear down this 2 liter. While searching to figure out exactly where this thing came from, in a very tiny subset of a very long document, I was able to decipher that this came from the UK. It was in fact a 2 liter out of the Argenta, a big saloon as they call it. So I tore it completely down, sent everything off to the machinist, had him check it out, clean up the deck, clean up the head, valve grind. Nothing fancy, just a stock grind. I had ordered these 10, I believe, 1/4 to 1 pop-up pistons from one of the Texas part suppliers. Made sure I dropped it off with the block and the heads so they could make sure everything was going to interchange well. And they called me up, said it was done, and everything looked great. The cams I ordered are kind of touted as a aggressive street cam. They are a regrind. So the one thing you need to be careful of on the cam boxes on these things, that if you're going to use a stock gasket, you're going to have to get some much thicker shims to take care of the base radius being ground down. So in light of taking out the gasket, I was stuck with using a chemical gasket, and I wasn't thrilled about using RTV. You've been using it for years, but this particular application I think required something a little different. So I decided to use anaerobic sealant. This stuff is got some rather unique properties to it, but it also flattens out to next to nothing. So while the machine work was being done, I had some time to kill, so it gave me time to research what parts I was going to put in this. Like I said, I used the somewhat aggressive street cams, the 10 1/4 pop-ups, the ITBs came from eBay, Gen V look-alike, shall we say. Going back to the camshafts, and if you're going to omit the gasket and go with the chemical one to keep your adjustment shims closer to stock dimensions, you're going to have to get some adjustable cam gears. That's due to the geometry change. This way all your marks continue to line up the way they're supposed to. Plus it gives you some fine tuning on the back end when you finally get to that point. I tried to work out as much of the details and physics of this motor build on the engine stand, so there wouldn't be a whole lot of difficult work to go on once it got out in the car. Things like the alternator position moved over to the right side of the car, Had to make a custom pulley to get the dimensions on that right. Just little things like that make it a whole lot easier just to drop the engine in and go from there. So I did a whole bunch of research, ended up buying the wrong manifold first. Finally finding this one on eBay that looked pretty good from the pictures, so I ordered it, waited for it to show up. When it got here, I started looking at the surface features, putting straight edges on it, and they weren't even close. So I straightened them out via a benchtop belt sander and then started to do port cleanup. One thing that struck me was there was only one vacuum tap, and that was on the number one runner. It was a 3/8 pipe tap, which seemed a little odd. Hit the brakes, and number one cylinder would go horribly lean for a few seconds. I've seen other people use the same manifold, just put it straight on and a couple of Webers on top of it and just go for it. I wanted to do a little more by cleaning up the ports, getting the radiuses much better, and just generally opening up things to fit these new ITBs. So I put in a pipe tap, filled it full of JB Weld, ported it down. JB Weld has a good bite into the threads, the existing threads. I've seen it do some pretty amazing things on race cars, so I wasn't too worried about it. So my thought was, where was I going to find unified vacuum in its current state? So I did a bunch of research, a bunch of thinking, came up with the idea of installing 4 brass tubes, one in each runner, making a small vacuum manifold that sits underneath the intake runners, that the brake booster and the map sensor can both have a nice steady vacuum source. Just a quick note, on the risers, the part between the top of the ITBs and the bottom of the air filters, I prototyped these out in PLA on the 3D printer. It worked good for fitting. I ran them for a little bit, but between the vibration and PLA just not liking to be compressed, the screws kept loosening up, so off to the CNC mill it went, and aluminum ones have now been fabricated. So once again, after a lot of research, as I suspected I had a TPS problem, I found this page from Haltech, who goes into great detail about how to identify which way is up, basically, on a TPS. Just click on the QR code. It'll take you right to it. It's great information. Kudos to them for putting it out there. And yes, of course, 50-50 chance I found the wrong way to hook it up at the beginning, because of course it didn't come with any instructions as to what was what. But it would give an incredible flat spot right off of idle. So found the problem, hopefully keeps other people from having the same problem. I originally designed a 3D air horn made from basic PLA printer material. It worked good for working out the physics and all the little details to make sure both ITBs were moving in sync. Ended up making one out of aluminum. Not the greatest work of all time, but it seems to work just fine. Plus, it gives you adjustment on the primary and secondary throttle bodies. I decided to go with a slightly bigger injector just due to there's going to be a lot more air in this engine. Gives me some more adjustability. The injectors I ended up going with were from mid-80s BMWs, pretty common number, but that gave me roughly a 20% overall increase in available fuel. So the vehicle came with a later model factory ignition system, uses the HEI 4-pin ignition module mounted to a giant heatsink and a standard coil. After all was said and done, finally got it running right. On a test drive, it decided it had enough. Misfiring, let it cool down a little bit. It came back to life just enough to get it home. A buddy of mine suggested, "Hey, why don't you check to see if any of the other HEI modules might have the output signal you're looking for?" And sure enough, if you use the later model 7-pin, they do have ignition control circuits, and they also have a 5-volt square wave output that the computer can use as its reference. Yay! After months and months of this project, I finally had a chance to start it. Wow, that has been a journey.